Alright, this video is about Basil J. Hiley's latest YouTube talk, and I discovered it last night. I wanted to see what his latest was on YouTube, and it turned out he was interviewed by this sort of science and meditation YouTube channel that I had never seen before. And so I've highlighted the parts of his talk that corroborate my own recent alien scientist talk. So I was amazed at how similar my talk was to his talk in many ways, and I have corresponded with Professor Hiley a couple times, and the first time was about 2018, and then just maybe maybe a year ago, 2020. And so the talk, I'll give the YouTube link. But I highlighted in orange, and so right away the person asking the question asks if there's an underlying reality that's similar to what's found in Buddhism from quantum mechanics. And basically he says he's not going to take on Buddhism in particular, but that he was raised in India, so it's kind of like he's hardwired to think that way, is what he's trying to say. And then let's see what else we find here. So he's saying that the quantum, what David Bohm called the quantum potential, is it has to respond to the collective behavior, even though there's no particles present at all. So he's saying that there's basically this non-local field, and this is what I mentioned in my talk, that Basil Hiley says at zero time there already is a non-local collective behavior, is what he's calling it here. And then it says, so then he's referring to, this is really nice right here, because he's making a connection between Fourier analysis or spectroplasy and spectroplasy. I think I'm saying that right. And from De Broglie. So he's given a hat tip to De Broglie, because Bohm realized that what he was arguing was what Louis De Broglie had already figured out. And so so then he's connecting that back from the nu here, that's the frequency. So the Planck's constant times the energy as the frequency, and then he's connecting it back to the photon wavelengths, which would be in the nanometers or the terahertz for frequency. And so this is important that they're discrete, because this is what non-commutative geometry argues, that there's a discrete algebra at the foundation of reality. So the fact that he mentions this, that de Broglie was talking about a stationary discrete state. So and then so then he's saying how, Schrodinger's cat, when Schrodinger devised that experiment of the cat, he was trying to tell people that quantum mechanics is not it's problematic. It needs something, a better explanation. And he's saying that this paradox hopefully would wake people up, but no, it's sort of become accepted. And yes, that's the way nature behaves. So he's saying that the Schrodinger's cat, like, it backfired and people now just accept it without thinking about what it really means, what it leads to this underlying reality. And so he's saying that the de Broglie Bohm, David Bohm model is a different model than the Bohr interpretation or any other of the numerous interpretations of quantum mechanics or quantum physics. He's even, okay, now he says it's changed into a religion that that this is the state of the particle. And so what the Bohm, the de Broglie Bohm model is stating is that the particle, this is a point I made on my alien scientist talk, that the non-local spin is not dependent on the particle. It's before the particle. It's like another field, but it's, and so but people are still, he calls it a religion. It's like a materialistic religion that people are attached to the particle and what state the particle is in. So then he's getting back to de Broglie, and another way to understand de Broglie is that frequency is to time as momentum is to wavelength. And so he's saying that this is what the quantum potential is that you have this extra term, which is the imaginary term of the Schrodinger equation. And this is what David Bohm discovered, is that basically it's the negative amplitude is what from what I remember, it'd be like the negative frequency before it's squared, before the amplitude is squared, so that because it's a imaginary number, you can have negative frequency and reverse time. So the reverse time is the negative amplitude, or what would be the wavelength, negative wavelength, and or reverse wavelength. Essentially, it's the phase. It's a reverse phase. So then he's kind of putting down Richard Feynman's called it, said nobody can understand quantum mechanics, and that's another way of the Bohr model, just saying, just forget about it and don't talk about it, and you don't need to do it. And so then, so he's saying, what is this quantum potential energy? It's very much like a kinetic energy that is stored up. And so then when you get the free particle again, the energy is fed back into the kinetic energy, and it goes bang like hell. So this, when he's referring to kinetic energy, this is actually that's a reference to relativity, because we think of the relativistic mass as kinetic energy. That's the proper term of it, is kinetic energy. And so then this is, because it's reverse time, it can be very small, but it's very powerful, and that's why they called it subtle. And so basically, he's saying, it's not mechanical. He's saying, he's relating it to biology now, and he's saying biology